the next sensor we'll be talking about is this sensor. This is a moisture slash water sensor, and basically how this works is that there are multiple traces, as you can see, along the sensor, and basically if any of the traces are shorted, that means if there's a connection between any of the traces, it can detect it and send a signal. The great thing about this sensor is that it's originally designed to detect water. So like imagine you put it on a surface, and if it's raining or there's some sort of leak, like you might use this as a leak detector, it can detect when water droplets fall on it. Alternatively, you could use this in a situation where you put this inside a potted plant, so like a plant, and you can measure how damp the soil is based on how much analog value it returns to your microbit. But what we're going to use it as a capacitive sensor. And if you use a smartphone, you know that it's a touch screen, right? We're going to make a touch screen with this. A smartphone uses something called a capacitance sensor, and that's the same sort of principle behind as we're going to use in this. So what we're going to do is how this works is actually our body is mostly water. You might have heard of the fact that humans are 70 to 80% water, and water is quite conductive. You must have heard that don't take your electronics inside the water because it can spoil. The reason is because water conducts electricity, and because electricity is conducted by water, and we are mostly water, we too conduct electricity. That's why if you've ever accidentally touched a wall socket, you might have shocked yourself. That's the exact same reason why. So we're going to do that, and because our body is so much water, whenever we touch the sensor can detect slight changes in the resistance, and we can also update that to the microbit. So we're going to just explore this feature first of all. So let's go to the overhead view. Before we go to the overhead view, let's go to the computer and just program a very simple code to just show the number as to the value of what the sensor is reading. And then we're going to go to the overhead view and look at just a few examples of what it looks like with water, what it looks like with the finger, and we'll do a project in the next video. So over on the computer side, I'm just going to do basic show number. I'm going to go into advanced pins and analog read. We're going to read analog, we can read anything. We can read pin 0, 1, or 2. I'm just going to read pin 1, and we'll test out how this works. So here's a water sensor. Depending on the exact water sensor that you guys get, you might have a slightly different arrangement as to the wiring. But remember how we discussed that yellow/orange is usually signal, red is power as in 5 volts, and black is ground. If you look on our sensor right here, we see an S, we see a plus, and we see a minus. So I'm going to align my cabling, and I'm going to plug it right in. Again, look at the data sheet for the sensor that you get. I'll link my sensor down below so you can purchase the exact same one. I've wired up my sensor now, and it's right here. Now what I'm going to do next is I'm going to use something called jumper cables, and these are these small little cables. Here, I'll pull them out, and I'm going to use alligator clips. Here, I'll show you what jumper cables are. Jumper cables are basically these little cables with these little pin endings, as you can see, like that. So I'm going to use a couple of these, and I'm going to connect them to my sensor header. So the sensor, remember, it connected like this from one side. From the other side, it has a connector like this, and I'm just going to connect these cables. So I'm going to connect just purple into black for now. Just going to connect red to red for now. Oops. Like that. And then I'm going to finally connect orange into the orange cable. Here, so you guys can see. It's orange into orange. So just remember the colors that you have used. You can use slightly different colors. It doesn't really matter. It's just what signal does each cable carry. You just need to remember that. So I'm going to use these alligator clips, and again we're going to wire it up to how we wired it in our code. If you use pin 1, then use pin 1. I used pin 1. You might have used pin 2 or pin 0, so whatever you used, just follow along. So the orange cable is a signal cable. Orange cable is signal cable. I'm going to connect that through my alligator clip to pin 1. So that's connected there. My next cable is my power cable, so I'm going to take that red cable, connected to 3 volts here, connected, and now I'm going to connect it to the sensor power input. So 1 second. Here, connected, and lastly I'm going to connect my my ground, or my negative in this case. So I take this alligator clip, press it in, and lastly connect it to the ground terminal on my microbit. So this is what your microbit should look like if you use the same pin 1 as me. Otherwise you can change this one right here to whatever pin you used, and let's plug it in and test it out. Okay, so I've flashed my code to the microbit, and here you can see the number on the screen. Right now it's showing a 3 and there's nothing on the screen. Let's try some water. So I've got a cup with some water over here. What I'm going to do is I'm going to take a drop in my finger, and I'm going to drop a single drop on the microbit, on the sensor, sorry, and here you can see the sensor close up with the water droplet on it. And if I put this down, you can see the reading on the microbit is 551. So if I spread this water droplet out a little bit so it covers more of the sensor, it should go up. So it's gone up to 702. 688. So it changes a little bit. Let's add some more water. I'll use my finger. So I've added a lot more water and spread it all out. So it's maxing out at around 699. So it's going to around 700, and that's the max it's going to when it's wet. So now I'll try drying it out. So I'll just use my finger and wipe down the sensor. After drying out the sensor, we can see the value goes back down to what looks like 11. So it's not fully dry yet. Here I'll dry it again. Now if you look, it's gone down to about 4. We can also use this project with soil moisture. So we can put this sensor within a potted plant. So as the soil moisture drops below a certain threshold, the microbit can start beeping to alert the user that, oh, your plant is getting very dry, it can die anytime soon, please water your plant. So yeah, these are some projects that are that can be made with the water sensor here. We're going to make this water sensor into a touch sensitive device, and we're going to use it to check how much pressure we're pressing on the sensor, and that'll be our next video. Thanks.